I will spend a few minutes talking about Ohm's law. So we are familiar with delta V equals IR. This is what we are. This is the form that we often use about Ohm's law. Now this means if you do a graph of delta V as a function of the current, then if you see you do some measurements, you will find, say you do the linear fit, you get the line. If you get the slope of this will give you the resistance. Now when we talk about Omic materials, this means that the resistance is constant. Okay, R, or if you want the slope from that graph, this should be approximately a constant. Okay, these are the Omic materials. Now, it is important to keep in mind that no material is truly ohmic. We are in physics, so we are dealing with approximations. Is it true that the slope is really constant for always? No, it is not. What we're talking about is that when you do this graph and you find the slope, you will find a resistance that is approximately the same, more or less, for different ranges of currents or potential difference. Okay, no material is truly ohmic. Now there are some. You may start here, and then as you increase the delta V, you may start here, and then your slope may increase. In this case, you can still say, if you want, you can still say the slope of that will give you the resistance. However, you need to keep in mind, for those non-ohmic materials, the resistance, the number that you have, the R, it will not be a constant. And this makes it less useful. Okay, the usefulness with Omic materials is that once you know what the resistance is, once you know R, you can use it independent of the potential difference on the current that you have flowing in your material. If you're dealing with non-ohmic materials and say you have that slope for a particular delta V, well, so what? You have one slope for only that particular value of delta V. You cannot use it if you change your potential difference for that object. So for non-ohmic materials, you will not really see often discussed R, the resistance, or the slope of delta V as a function of I. Okay, when you do an experiment and when you deal with resistors, then those are made from materials that are approximately ohmic. Okay, which means you can say that R is a constant. But when we talk about a light bulb, for example, this is, if you do the graph of delta V as a function of I, you will see that for a bulb the resistance is not constant. And even if you do just a few measurements, you don't have to do the entire graph, just do a few measurements and you will still see the resistance for a bulb is changing as you change the delta V across the bulb. So the bulb is made from the filament of the bulb is made from non-ohmic material.